Hi there, welcome to my channel. In this video, I'm going to discuss more questions on probability, and mostly it is SPM formatted questions. Okay, let's start with question 1. Aniza's telephone number is 5487069. One digit is chosen at random from this number. Consider the following events. A is an event that a digit less than 6 is chosen. B is an event that a multiple of 3 is chosen, and C is an event that a factor of 42 is chosen. Determine whether the following pairs of events are mutually exclusive. Okay, now before we determine that, we list out all the elements for the sets here. So we start with sample space. So sample space consists of digit 5, 4, 8, 7, 0, 6 and 9. Next, event A, where event A consists of digits less than 6. So that will be 5, 4 and 0. You need to refer to the sample space and list out the elements for event A. Next, event B, multiple of 3. So we have 6 and 9. Okay, and the last one is event C, where event C consists of factors of 42. So here we have 7 and 6. Okay, so let's look at the question again. Determine whether the following pairs of events are mutually exclusive. Now before that, you need to know what is mutually exclusive events. So remember, mutually exclusive event means the events cannot happen together. Remember, mutually exclusive event, they cannot happen together. The events cannot happen together. That means there will be no intersection between the events. Okay, so for event A and B, if you see, look at the list here, there is no intersection between event A and event B. That means there is no common element. Okay, therefore we can conclude that A and B are mutually exclusive events. Why? Because the intersection between set A and B equals to an empty set. Next, question B, you have to compare event B and C. Okay, if you compare event B and C, here we have common element, that is 6. Okay, since we have intersection between B and C, therefore B and C, they are non-mutually exclusive events. Okay, and the reason, because the intersection between B and C not equals to empty set. Okay, and the last one, you compare set A and C. Okay, compare event A and event C, and you will come to a conclusion that A and C does not intersect. Therefore, these two events are mutually exclusive events. Doesn't intersect means they cannot happen together. Okay, so here the reason A intersects C equals to an empty set. Question 2. Two events A and B are such that probability A equals to 1 over 5, probability B equals to 3 over 4, and probability of A union B equals to 1 over 4. Find the value of probability of A intersect B, or probability of A and B. Now, the formula of probability of A union B can be written as probability A plus probability B minus probability of A intersect B. Okay, make sure you remember this formula. Now, since here we are given the value of probability of A union B as 1 over 4, we substitute the value into the formula. Okay, we are also given probability of event A as 1 over 5 and probability of event B as 3 over 4. Now simplify this in order to obtain the value of probability of A intersect B. Okay, simplify this and your final answer will be 7 over 10. Okay, question 3. Two independent events A and B are such that probability A equals to 1 over 3 and probability B equals to 2 over 5. Find the probability of A union B. Okay, now here remember you are given that event A and B are independent events. Therefore, we do have value for probability of A intersect B or probability A and B, which can be calculated using the formula probability A times probability B. Okay, now you have the value for probability A and probability B. So substitute and here you can find the probability of A and B. Remember, when you come across the word and, you have to multiply. Or in other words, if you have the intersection between two sets, you multiply in order to get the answer. Next, okay, if you still remember this formula, probability of A union B, okay, it is equals to probability A plus probability B minus probability of A intersect B. Okay, since we have all the values, substitute and simplify to get the answer. Question 4. Three mutually exclusive events A, B and C are such that probability A equals to 1 over 7, probability B equals to 1 over 4 and probability C equals to 3 over 8. The first question, you are asked to find the value of the probability of the intersection between event A and B. Now, refer to the question again. It is stated that the given three events, they are mutually exclusive. So what is mutually exclusive? The events cannot happen together. That means there will be no intersection between the sets. Therefore, the first answer will be 0. Means probability of the intersection between event A and B equals to 0. Why 0? Because the events are mutually exclusive. That means cannot happen together. That means there will be no intersection between the events. Okay, question B. You are asked to find the probability of the union of set A, B and C. So you can write the formula first. Okay, so the formula will be probability A plus probability B plus probability C. Then you have to minus with the intersection, the probability of the intersection between event A, B and C. And again, since these events are mutually exclusive, therefore the intersection between these three events equals to 0. Okay, so now you just have probability A plus probability B plus probability C. Substitute all the values and simplify in order to get the answer. Question 5. You are given the table consists of events and probability of event occurring. Okay, so probability of event X equals to 2 over 5, probability of event Y equals to 1 over 10, probability of the intersection between X and Y equals to 3 over 10, and the probability of the union of set X and Y equals to K. Okay, so here you are asked to find the value of K. So write the formula of probability of the union of X and Y. So here it will be probability X plus probability Y minus probability of the intersection between X and Y. Okay, substitute the value. So probability x is 2 over 5 plus probability y minus the intersection. Okay, so simplify this and you will get the answer as 1 over 5. Question 6. In a box, there are k white, 8 black and 6 green balls. A ball is chosen at random from the box. A ball. That means only one ball is being chosen. Okay, given the probability of choosing a green or a white ball is 4 over 5. Okay, when in the presence of or, remember it can be mutually exclusive event or non-mutually exclusive event. That means choosing a green ball and a white ball at the same time. Is it possible? You must think about it. Okay, now the question is to find the value of k. So what is k? K is number of white balls. Okay, to start with, we define the events. So let A equals to choosing a green ball and B as choosing a white ball. Okay, and the number of sample space, we have k plus 8 plus 6 equals to k plus 14. Now, go back to the question. So here the given information is choosing a green or white ball. Or, remember the word or also can be replaced using the symbol union. Therefore, we are going to use this formula. Probability of the union of set A and B equals to probability A plus probability B minus the probability of the intersection between A and B. Okay, so again remember the word or can be replaced using the symbol union, and the word and can be replaced using the symbol intersection. Okay, now let's go back to this answer here. So probability of the intersection between A and B. Intersection between A and B. Can event A and B happen at the same time? That is choosing a green and white ball at the same time. It is impossible. Why it is impossible? Because we are only choosing one ball. So it is impossible to get green and white at the same time. Therefore, the intersection here equals to 0. Now let's continue. So here you are given the probability A or B as 4 over 5. Substitute. And the formula of finding probability event A will be number of event A over number of sample space plus number of event B over number of sample space. Okay, substitute the information given. Number of event A, that is getting a green ball, we have 6 out of k plus 14, plus number of B, that is number of white ball. Here we have k white balls. Okay, so k over number of sample space, k plus 14. Okay, if you look at the fractions, the denominator is already same, so you can combine it as this 6 plus k over k plus 14. Okay, cross multiply, expand, rearrange in order to find the value of k. So here you have 5k minus 4k equals to 56 minus 30. Therefore, the final answer k equals to 26. Question 7. The probability that 3 teams A, B and C win a hockey match given as 1 over 4, 1 over 5 and 1 over 7 respectively. Calculate the probability that team A or team B win the match. So when you come across the word or, remember the word or can be replaced using the symbol union. Okay, so it can be written as probability of the union between set A and B. So it is same as probability A or B. Okay, the formula is probability A plus probability B minus the probability of the intersection between A and B. Now intersection, can team A and team B win at the same time in a match? So that is impossible to happen. Okay, only one team will be the winning team. So here event A and event B cannot happen together. That means team A and team B winning the match at the same time. It is impossible. Therefore, it is mutually exclusive event because these two events cannot happen at the same time. Therefore, the intersection between set A and set B equals to 0. Now you can calculate the probability. Here you are given the probability of team A winning the match, that is 1/4, plus probability of team B winning the match given as 1/5. Okay, simplify and you'll get the answer as 9/20. So again, remember, when you are given the word or, it is same as using the symbol union. Okay, and when you have the word or, you need to check whether the events are mutually exclusive or non-mutually exclusive event. So if it is mutually exclusive, therefore the intersection will be 0. Okay, question B. Probability A, team A or team B or team C win the match. Again the word or. Therefore you can replace the word or with the symbol union, and the formula will be probability A plus probability B plus probability C, then minus with the probability of the intersection between A, B and C. Again, team A, B and C cannot win at the same time. That means these three cannot happen at the same time. Therefore, the intersection between these three events equals to 0. So left only probability A plus probability B plus probability C. All this information is given. You substitute and find the final answer. So the final answer will be 83/140. There are 40 students in 5 Science 1. 30 of them like additional mathematics, 20 of them like physics, and 15 like both the subjects. If a student is chosen at random, find the probability that the student like physics or additional mathematics. Okay, let's define the events. So we take AM as student who like additional mathematics and P for student who like physics. Okay, so here for the first question, you are asked to find the probability students like physics or additional mathematics. So you can simplify it as probability in bracket P or AM. And the formula will be probability P plus probability AM minus probability of the intersection between P and AM. Okay, so probability P, so probability student like physics. So number of students who like physics is here given as 20. So 20/40. From where did I get the 40? The number of students in the class. Okay, given as 40. Plus probability of additional mathematics. Additional mathematics, there are 30 of them who like additional mathematics. So 30/40 minus 15/40. So 15 here for students who like both the subjects. So 15/40. Okay, simplify this. You will be able to get the answer for the probability that the student like physics or additional mathematics. Now for the second question, probability that the student like physics and additional mathematics. So if you come across the word and, then you have to multiply. So probability P and AM. So probability P times probability AM. So 20 over 40 times 30 over 40. Simplify and you will get the answer. Question 9. There is a 40% chance that Ali will score a goal in a football match. Find the probability that out of 2 consecutive matches, Ali scores goal in both matches. So let's define the events. So G as event of scoring a goal and G prime as not scoring a goal. So probability G here equals to 40 over 100. Why 40 over 100? Because it is given 40% chance that Ali will score a goal. Okay, and G prime, probability of G prime will be 1 minus 40 over 100 equals to 60 over 100. Okay, so the first question you are asked to calculate the probability that Ali scores goal in both matches. So that will be PGG. First time goal, the second time also he scores a goal. So G and G. So it involves the word and. Therefore you have to multiply. Okay, so here it is independent event, so you multiply, therefore you have 40 over 100 times 40 over 100, and the final answer will be 4 over 25. The second question, you are asked to calculate the probability that Ali scores goal at least once in each match. At least, when you come across the word at least, it is simple if you just apply this formula. 1 minus the probability of the complementary events. So here 1 minus G prime, G prime. Probability of G prime and G prime. Okay, so 1 minus G prime here is 60 over 100 times 60 over 100. And your answer, final answer will be 16 over 25. So just remember, when you come across the word at least, you just take 1 minus the complementary, probability of the complementary of the events. Probability that Latif and Amir are selected for a football match are 1 over 3 and 1 over 5 respectively. Calculate the probability that both of them are selected. Okay, before that we define the events. So let's say L as event of selecting Latif and A as event of selecting Amir. Okay, so here you are given the probability that Latif is being selected as 1 over 3. That means not being selected will be 1 minus 1 over 3, which is equals to 2 over 3. And for Amir, probability Amir being selected given as 1 over 5. So probability not selected will be 1 minus 1 over 5 equals to 4 over 5. Okay, so for the first question, both of them are selected. That means Latif and Amir is being selected. So Latif and Amir. Therefore, you can rewrite it as probability Latif times probability Amir being selected. So we have the values of the probabilities here. So substitute and get the answer. For the second question, one of them is being selected. Okay, so if that means only one is being selected. It can be Amir selected, Latif not selected, or Latif selected, Amir not selected. Okay, so we have two possible outcomes here. So it can be probability L and A prime, or probability L prime and A. Okay, so in order to get the probability of Latif selected, Amir not selected, so Latif selected is 1 over 3. Amir not selected, here we have 4 over 5. Or, so when you come across the word or, you change it as plus the other outcome, the other possible outcome, Latif not selected and Amir selected. So Latif not selected, the probability is 2 over 3 times Amir selected is 1 over 5. So simplify and get the answer. So the final answer here we have 2 over 5. The probability of Afrina being chosen as a school hockey player is 5 over 7, while the probability of Danisha is being chosen is 8 over 11. Find the probability that neither of them is chosen as a player. Okay, so first we define the events. So A as choosing Afrina, D as choosing Danisha. Okay, so probability A here is given as 5 over 7. Therefore, probability A prime, that is Afrina not being selected, that will be 1 minus 5 over 7, which is equals to 2 over 7. Next, probability that Danisha is being selected, given as 8 over 11. Probability Danisha not being selected, that is D prime, equals to 3 over 11. Okay, so with that, okay, let's continue with the question. Okay, so find the probability that neither of them is chosen as a player. Okay, so probability A prime and D prime, I mean both of them not being selected as a player. So here you can rewrite it as probability A prime times probability D prime. So we have the information of A prime, probability of A prime and D prime. Just use the information and find the answer. Okay, for the second question, you're asked to find the probability only one of them is being chosen as a player. Okay, it is similar as the question before this. So here it can be Afrina being selected, Danisha is being rejected, or Afrina is being rejected, Danisha is being selected, because the question is only one of them is being chosen as a player. So here probability A and D prime. So probability A is 5 over 7 times D prime 3 over 11. Next, plus with the other outcome. The other possible outcome is Afrina not being selected, but Danisha is being selected. So A prime and D. So probability A prime 2 over 7, probability D 8 over 11. So multiply this and simplify, and the final answer is 31 over 77. The diagram shows 6 number cards. One card is chosen at random from the 6 cards. Find the probability that the number chosen is a multiple of 3 and a factor of 24. Okay, first we list out all the sample space. So here sample space we have 6, 5, 6, 2, 15, 4 and 12. Okay, let's define A as the multiple of 3. Okay, referring to the sample space, multiple of 3, we have 6, 15 and 12. Next, B as factor of 24. So factors of 24 will be 6, 2, 4 and 12. Okay, for the first question you are asked to calculate the probability that the number chosen is a multiple of 3 and a factor of 24. N. Okay, so when it comes to the word n, that means you have to multiply. So probability even A times even B. So probability A we have 3 elements, 3 out of number of sample space 6. So 3 over 6 times probability of even B we have 4 elements altogether. So 4 over 6. Simplify this and you will be able to get the answer. Okay, another option, you can find the intersection between set A and set B. So the intersection between set A and set B will be digit 6 and 12. So we have 2 elements. So probability of the intersection between A and B will be 2 over 6, which is also equals to 1 over 3. Okay, next let's move on to question B. Okay, here you are asked to find the probability that the number chosen is a prime number or an even number. So let's define C as the prime numbers. So prime numbers from the sample space we have 5 and 2. Even number 6, 2, 4 and 12. So we define D as even number. Okay, now and here we have intersection between set C and D. Okay, that is 2. Therefore, the number of elements for the intersection between C and D equals to 1. Okay, now, so here you are asked to find the probability that the number chosen is a prime number or an even number. Okay, so you can write the expression as P for probability in bracket C or D, event C or D. Okay, so the formula will be probability C plus probability D minus probability of the intersection between C and D. Okay, probability C we have 2 out of 6 plus probability D set D we have 4 elements, so 4 out of 6 minus the intersection between C and D, we have only 1 element, so 1 over 6. Okay, and simplify and you will get the answer. Azman competes with Budi in a badminton match. The match will end when one of the players wins 2 sets. The probability of Azman winning any set is 2 over 5. Find the probability that the match ends after only 2 sets. So here, let's define the events. So let A as event of Azman winning a set, B as event of Budi winning the set. Okay, so the first question, find the probability that the match ends after only 2 sets. That means it have to be Azman win the first set and then followed by Azman again wins in the second set, or it can be Budi wins the first set, again he wins the second set. So now we have 2 possible outcomes here. Okay, either Azman win the first 2 sets or Budi wins the first 2 sets. Okay, so probability Azman wins given as 2 over 5. So 2 over 5 times another 2 over 5. Probability A and A. That means probability A times probability A. Therefore, it is 2 over 5 times 2 over 5. Or probability B, Budi wins the match. So if Azman is 2 over 5, Budi will be 3 over 5. How to get the 3 over 5? 1 minus 2 over 5. So probability Budi wins times probability Budi wins the second time. So 3 over 5 times 3 over 5. Simplify and you'll get the answer. Okay, next question. B. Find the probability that Azman wins the match after playing 3 sets. So in order to win, he have to win 2 sets, but now they are playing 3 sets. So it can be like this. Probability Azman Budi, or probability Azman Budi Azman, or probability Budi Azman. Okay, now if you look at the first outcome, Azman wins, and then followed by Budi wins. Now here they won't play 3 sets. Why? Once Azman wins for the first 2 sets, then the game will be ended. Therefore, you cannot include the first outcome here. Okay, therefore you have only 2 possible outcomes. That means first set Azman win, the second set Budi wins, and the third one again Azman wins. So they are playing 3 sets and Azman wins. Or first set Budi wins, second set Azman win, and the third one also Azman wins. And for this event Azman will win the match. So here we have 2 possible outcomes, so that Azman win the match after playing 3 sets. Okay, so the first outcome A, B, A, that means probability A 2 over 5 times probability B 3 over 5 again times probability A, that is 2 over 5. Or, so when it comes to or, you change it as plus the other possible outcome. First Budi, so Budi will be 3 over 5 times probability A 2 over 5 again times probability A 2 over 5. Simplify and you will able to get the answer. Okay, now here you are given table with color and number of marbles. Okay, 2 marbles are chosen at random from the box. Find the probability that both marbles are of the same color. Okay, so here first we list out all the possible outcomes. Okay, and before that we define the events. So let G as event of choosing green marbles, R as event of choosing a red marble, Y as event of choosing yellow marble. So here we want probability that both marbles are of the same color, so that will be probability green and green. Remember, we are choosing 2 marbles, so first marble is green followed by the second marble is also green. Okay, or it can be red and red and red. Okay, or it can be yellow and yellow. Okay, so we don't have any other color, so these are the 3 possible outcomes. Okay, remember, when you have P green and green, you have to multiply. When it comes to or, then you plus. So probability green and green, change the or to plus. Okay, so green and green, so you multiply. So green we have 7 over total we have 15 marbles. So 7 over 15 times, for the second pick the number of green marbles will be reduced 1. Okay, therefore we have only 6 over 14. Why 14? Because for the first time total we have 15 marbles. Once you pick the first marble, for the second pick you have only 14 marbles left. Okay, so this is the first possible outcome. Or it can be P red and red, probability of red and red marble. So probability red for the first time, that will be 5 over 15 times reduce 1, so 4 over 14. Or for yellow marbles we have 3 over 15 times, for the second pick yellow left only 2 over total marbles 14, so 2 over 14. Okay, simplify and you'll be able to get the answer as 34 over 105. Okay, with that we have come to the end of the lesson. Okay, so thanks for watching and please do subscribe for more videos.